This is SpaceTime Series 29, Episode 48, for broadcast on the 22nd of April 2026. Coming up on SpaceTime, discovery that young sun-like stars dim quickly, good news for the possibility of life, a surprisingly speedy solar wind discovered in the inner corona, and the Dream Chaser spaceplane passes another critical milestone. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has discovered that young sun-like stars tend to settle down and start to dim much more quickly than previously thought, and that could potentially benefit any orbiting planets and the prospects of life developing there. The findings, reported in the Astrophysical Journal, are based on new observations by NASA's Earth-orbiting Chandra X-ray Space Telescope. Astronomers use Chandra and other telescopes to monitor how powerful radiation from young stars, often in the form of dangerous X-rays, can pummel any planets orbiting around them. However, they didn't know how long this high-energy barrage would last. And that's where the new observations come in. Astronomers studied 8 clusters of stars between 45 and 750 million years old. The authors found that sun-like stars in these clusters unleashed only about a quarter to a third of the X-rays they're expecting. The study's lead author, Konstantin Getman from Penn State University, says the observations reveal a natural quietening of young sun-like stars in X-rays, possibly because their internal generation of magnetic fields becomes less efficient. And Getman believes this calming could have been a boom for the formation of life on planets around stars that are younger versions of our own 4.6 billion-year-old sun. That's because large amounts of X-rays can erode a planet's atmosphere, preventing the formation of molecules necessary for organic life as we know it. On average, 3 million-year-old stars with a mass equal to that of the Sun produce around 1,000 times more X-rays than our Sun does today. Meanwhile, 100 million-year-old solar mass stars are about 40 times brighter in X-rays than the present-day Sun. And it's possible that we owe our own existence to our Sun doing the same thing several billion years ago. The authors found that stars with about the same mass as the Sun quieten down relatively rapidly after just a few 100 million years, while those with less mass kept up their high level of X-ray emissions for much longer. Combined with the decrease in the energy of the X-rays and the disappearance of energetic particles, the Sun-sized stars are apparently better suited to host planets with robust atmospheres and possibly blossoming life than previously thought. Getman and colleagues also used data from the European Space Agency's Gaia satellite and the Rosat mission. This allowed them to identify stars that were members of clusters rather than either foreground or background stars. To measure the X-ray outputs from the stars, the authors made new Chandra observations of 5 clusters with ages between 45 million and 100 million years, in addition to using Chandra and Rosat data from archives to study 3 older stellar clusters with ages between 220 and 750 million years. Astronomers hadn't previously been able to study the exact X-ray output of stars in this age range. Most have relied on sparse data and a relationship from previous work between the X-ray emissions produced by young stars and their ages and spin rates. Older, more slowly rotating stars are usually fainter in X-rays. But the authors found that X-ray output drops off about 15 times more rapidly than the relationship predicts during this specific adolescent phase. While they're still investigating the cause of this slower-than-expected activity, astronomers think the processes that generate magnetic fields in these stars may become less efficient, and that would lead to the stars becoming quieter in X-rays more quickly as they age. This is SpaceTime. Still to come, a surprisingly speedy solar wind found in the Sun's inner corona, and the Sierra Space Dream Chaser spaceplane Tenacity passes another critical milestone. All that and more still to come on SpaceTime. A new study has found that the solar wind is travelling up to 4 times faster than expected in the Sun's inner corona. The solar wind is a constant stream of charged particles flowing out from the Sun. The new findings, reported in the Astrophysical Journal Letters, provides fresh details about the inner workings of our local star. The discovery marks the first result from the European Space Agency's Proba 3 mission. Proba 3 comprises 2 spacecraft flying in millimetre-precise formation. The exacting nature of their orbit allows one of the vehicles to directly occult or block out Sun from the other, in the process creating an artificial solar eclipse. This allows astronomers to study the Sun's faint, wispy corona, that's the atmosphere of the Sun normally obscured by the Sun's glare. The Proba 3 mission launched last year and has so far created 57 artificial solar eclipses, collecting more than 250 hours of high-resolution videos of the Sun's atmosphere. Before Proba 3, a solar eclipse seen from Earth was the best way to see the Sun's inner corona. See, when the Moon blocks out the Sun's direct light, scientists can capture details in the solar atmosphere around the Sun. The problem is total solar eclipses only happen on average once every 18 months or so. And when they do happen, totality, that's when the Moon totally blocks out the Sun, usually only lasts for a few minutes at most. So the observations by Proba 3 amounts to the same amount of observing time as 5,000 solar eclipse campaigns on Earth. This is the first time astronomers have been able to carefully track how material from the Sun moves through the inner corona where space weather is born. For around 5 hours at a time, the occulter spacecraft acts like an artificial moon, blocking out the Sun's direct light so the other spacecraft, the chronograph, can see the Sun's corona. And Proba 3's chronograph instrument can see down to 70,000 kilometres above the Sun's surface. That's 1/10 of the Sun's radius. No other space-based chronograph can observe the light scattering off particles in the Sun's corona this close to the solar surface. The instrument takes 1 or 2 images a minute. These are then combined into videos that reveal never-before-seen movement in the hard-to-observe inner corona. ESA's Proba 3 project scientist Joe Zender says these sorts of intricate movements have never previously been observed in optical wavelengths so low in the Sun's inner corona. Zender says Proba 3 can track how the solar wind speeds up through the Sun, showing speeds and accelerations that are surprising scientists. Just like wind here on Earth, the solar wind can be fast or slow, smooth or gusty. A fast solar wind usually flows in smooth currents from magnetic structures called coronal holes. In contrast, slow solar winds are variable and gusty, making understanding how it all works more difficult. Scientists think the slow solar wind is generated by the Sun's magnetic field lines, changing how they connect, merge and separate. This process pushes out blobs of plasma in large bright rays in the corona called streamers. In the inner corona, a region difficult to observe, astronomers saw slow solar wind gusts moving 3 or 4 times faster than expected. Previously, scientists had found that close to the Sun's surface, the solar wind should have been travelling at speeds of around 100 kilometres per second, but instead they tracked some of these blobs of plasma moving at between 250 and 500 kilometres a second. Overall, the wide range of speeds, accelerations and movement directions in the data explain why the slow solar wind is so hard to understand. It's naturally not uniform, involving lots of small-scale structures in the Sun's magnetic field, which astronomers can now see thanks to Proba 3. The discovery comes just weeks after contact was re-established with one of the spacecraft, which had suddenly gone silent following an onboard glitch, the cause of which is still being investigated. Zender says this first data set is just the beginning of a much longer journey to fully understand what's happening in the Sun. Most of the data collected by Proba 3 so far is yet to be analysed. Key open questions yet to be answered include finding out exactly what accelerates the solar wind, how the Sun flings out material in coronal mass ejections, and why the solar corona is so much hotter than the surface of the Sun. After all, things are supposed to get cooler the further away you get from the heat source. This report on the brilliance of the Proba 3 mission from ESA TV.
During a solar eclipse, the Earth is plunged into darkness and the Sun's ghostly atmosphere becomes visible. But what exactly causes solar eclipses? And how do scientists create their own artificial solar eclipses? And how will our mission, Proba 3, generate artificial solar eclipses on demand? Let's find out. So, how do solar eclipses happen? The answer is simple. It's when the Sun, Moon and Earth are perfectly aligned and the Moon covers the entire disk of the Sun. The fact that solar eclipses happen at all is a cosmic coincidence. It just so happens that the Sun is 400 times bigger than our Moon. but also 400 times further away, so the two bodies look the same size in our sky. Solar eclipses are extremely valuable because they allow scientists to study the sun's atmosphere, also known as the solar corona. Scientists are particularly interested in this region of the sun because it's the source of solar wind and space weather, which can impact satellites and Earth. These effects are especially noticeable during coronal mass ejections, enormous bubbles of superheated gas ejected from the sun. The solar corona is 1 million times fainter than the sun's surface, so the light from the solar disk needs to be blocked in order to see it. This is why eclipses are ideal for studying this region, and scientists trek all over the world to see them. Unfortunately though, solar eclipses are a rare phenomenon, occurring only for a few minutes every 18 months or so. But how do we know anything about the solar corona, given that eclipses occur so rarely? Scientists use coronagraphs, special telescopes that use a disk to block the sun's bright surface. In other words, a coronagraph produces an artificial solar eclipse.
And liftoff of Soho.
Coronagraphs are not only used on the ground but also in space. Previous sun-observing missions such as SOHO incorporate coronagraphs to study the corona, but their effectiveness is limited. Mimicking a real solar eclipse is difficult. When using a coronagraph, light spills around the edge of the disk, distorting the view we get. The best way to minimise this spillover stray light is to move the disk further away from the telescope lens. But how much further away? Approximately 150 metres, the length of 1.5 football pitches. And sending something that big into space is just not a practical idea. So how can we create a perfect artificial solar eclipse in space? This is where our Probe 3 mission comes in. Instead of relying on a single, impractically long coronagraph, Probe 3 consists of 2 spacecraft, a camera satellite and a disk satellite. They fly together so precisely that they operate like a single coronagraph, around 150 metres long. One spacecraft blocked the sun, creating an artificial eclipse, while the other observed the sun. To make this possible, the 2 spacecraft have to stay positioned with millimetre scale accuracy to create artificial solar eclipses on demand, significantly advancing our understanding of this mysterious region.
This is Space Time. Still to come, the Dream Chaser spaceplane Tenacity completes a major acoustic test milestone for NASA, and later in the Science Report, engineers and scientists looking at ways to save Venice from the threat of rising sea levels. All that and more still to come on Space Time. The Sierra Space Dream Chaser spaceplane Tenacity has just completed launch acoustic testing at NASA's Space Systems Processing Facility. The key milestone event validates the vehicle's ability to withstand the intense vibrations produced during launch. The test, in a specially designed hangar at the Kennedy Space Center in Florida, uses an array of 90 stacked giant speakers to simulate the sounds and vibrations experienced during blastoff. The Dream Chaser spaceplane was positioned at the center of the test setup with its wings stowed, mirroring the configuration it would have when it's mounted inside the 5-meter payload fairing during an actual launch. The successful test validated the durability of Dream Chaser's critical electronic systems and confirmed the structural integrity of the spacecraft. So, Dream Chaser has now achieved several key milestones, including EMI and EMC testing, high-speed tow testing, and post-landing recovery rehearsals. It's also demonstrated command and telemetry capabilities with mission control using NASA's Tracking and Data Relay satellite system. With the acoustic testing now complete in Florida, Dream Chaser has been transported back to Colorado for final modifications and mission-specific upgrades. Sierra Space Dream Chaser Program Manager Dan Polis says it's a key step in getting the spacecraft ready for flight. Now, NASA's slated Dream Chaser's Tenacity for an initial 6 missions, its first possibly later this year. That 45-day flight won't visit the International Space Station, but instead undertake low Earth orbit testing. Although originally designed to carry crews of up to 7 to the International Space Station, the reusable wing spaceplane will only be used by NASA to transport cargo and supplies to and from the orbiting outpost as part of NASA's Commercial Resupply Services 2 contract. Dream Chaser is capable of carrying 5,000 kilograms of pressurized and 500 kilograms of unpressurized cargo during the ascent phase on its uphill climb to the space station. And on its return to Earth, it can carry up to 1,750 kilograms of cargo and returned experiments. But the spacecraft is designed to be fitted with an expendable pressurized cargo module called Shooting Star attached aft. That'll increase its cargo capacity by an additional 4,500 kilograms. Right now, Dream Chaser is designed to fly aboard a United Launch Alliance Vulcan Centaur rocket. After docking with the orbiting outpost and completing its mission, it'll then return to Earth, gliding to a soft landing on the former Space Shuttle runway at the Kennedy Space Center. With Tenacity completing the final stages of its development before being handed over to NASA, Sierra Space are now building a second Dream Chaser, this one named Reverence. And there are plans for a specialised third Dream Chaser as well, but that'll be part of a classified national security contract, so no details are being released. There's even the possibility of a fourth Dream Chaser, this one for the European Space Agency, specifically modified for launch aboard an Ariane 6 rocket. Exciting times ahead. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Scientists say long-term HIV remission has been achieved in a patient following a stem cell transplant from a sibling carrying a specific genetic mutation. A report in the journal Nature says the 63-year-old man was diagnosed with HIV-1 subtype B back in 2006 when he was aged 44. In 2020, he received a stem cell transplant from a sibling with a CCR5 delta 32 mutation to treat a type of blood cancer. Over time, the donor cells were found to replace the patient's own immune cells in blood, bone marrow and gut tissues. Analysis of biopsies taken 2 years after the transplant showed no HIV genetic material integrated into the DNA of the man's infected cells in blood or gut samples. And further analysis of the man's cells showed no virus capable of multiplying. The human immunodeficiency virus HIV attacks the immune system, causing acquired immune deficiency syndrome or AIDS, which allows opportunistic diseases normally easily combated by the body to take hold and eventually kill the patient. The World Health Organization says since first being identified back in 1981, AIDS has killed over 44 million people globally and infected up to 115 million others, with 1.3 million new infections occurring annually. HIV is transmitted through body fluids. Although there is no cure, it can be controlled using a combination of complex drug cocktails. Engineers and scientists have selected 4 potential strategies for trying to save the city of Venice from rising sea levels. The findings, published in the journal Scientific Reports, looked at movable barriers, ring dikes, closing the Venetian lagoon, or relocating the entire city as potential strategies. The authors say adding additional measures to the current movable barrier system could be effective against sea level rises up to 1.25 metres. They use localised sea level rise projections over the next 300 years based on the IPCC's 6th assessment report to examine both the existing and potential new adaptation strategies for saving Venice. They investigated protecting the centre of Venice with dikes that would separate it from the rest of the lagoon, closing the entire lagoon with a super levee, or relocating the city, its residents and historic landmarks inland. According to the authors, relocation of the entire city could be necessary under the very high emission scenario with 4.5 metre sea level rise, which is projected to occur after the year 2300. A new study has warned that half of all health and medical questions supplied by 5 artificial intelligence chatbots are problematic. The findings, reported in the British Medical Journal, follow a test in which Gemini, DeepSeek, Meta AI, ChatGPT and Grok were challenged to answer 10 open-ended and closed questions in each of 5 categories: cancer, vaccines, stem cells, nutrition and athletic performance. The prompts were designed to be similar to common information-seeking health and medical queries and misinformation tropes. And the authors found half of the responses were problematic, 30% somewhat, and 20% highly concerning. They found the quality of the responses didn't differ among chatbots, but Grok generated more highly problematic responses than expected, while Gemini generated the fewest. The chatbots appear to perform best in areas of vaccines and cancer, and worst in areas of stem cells, athletic performance, and nutrition. Well, there's growing talk in technology circles about the next big revolution in communications, the 6G network. 6G, the upcoming 6th generation cellular network technology, is expected to launch commercially by around 2030, promising speeds of up to a terabyte per second, which is 100 times faster than 5G and 1,000 times faster than most current home internet systems, along with near zero latency. 6G will focus on integrating artificial intelligence native technology, advanced sensing, and expanded connectivity to include satellite networks, enabling applications like holographic communications, precise digital twins, and autonomous drone fleets. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
This is still at least a good couple of years away from being launched. Normally it's 10 years between each generation, and the 2020 was meant to be when 5G started, but we had 5G from about 2018 because it was in time for the Olympics in South Korea at the time. The Olympics is great for new TV sales, and obviously with being able to transmit high amounts of data, then, from far-flung places. Now, we take all this for granted these days, but when 5G was first being announced, there were lots of promises that you would have much better connectivity at the edge and have faster speeds. And I noticed that 5G, had a dirty little secret, which was that 4G could be faster many times than 5G. And I was always amazed that, I could connect to the 4G network and do a speed test and get faster speeds. But part of the appeal of 6G is that it's going to be better than 5G. So what does that mean exactly? Well, in this case, you've got artificial intelligence being integrated into the network core. So you're going to have what they call native wireless sensing capabilities for environment mapping, and they're going to be using higher frequency bands. When they use higher frequency bands, that's when you can get much faster data speeds, so you can really send huge amounts of data. And we had this with 5G with millimeter wave. You had to be effectively right next to the tower to be able to get those speeds, and the signal could be stopped by the glass in your window. So there's still a lot of work to do to make sure that those higher bandwidths can be widely propagated. And given the fact that they're at these higher frequencies, that's a problem. Part of the good thing about 3G was that it could operate on 750 megahertz of bandwidth. And that's the same sort of frequency that TV antenna signals come through to your house. They have to go through the house if you have one of the rabbit ear antennas. And so there's a lot of talk about 6G at the moment. I mean, the standard hasn't finally been finished, and after the debacle of 5G not really being much better than 4G, a bit of a over-promising and under-delivering sort of situation. And with plenty of places still, not rolling out 5G networks as big as the 4G networks. I mean, we have 2G gone in many countries, but not all. We have 3G gone in Australia, but not in other countries. And 4G and 5G will be with us for some time yet. And 6G, I mean, there may be some early announcements in 2028, 2029, new early devices that have it, but it's going to take several years. It won't be until 2035 that 6G handsets will be totally commonplace and that people will be using those networks. And we're yet to truly see how AI can help with propagating the signal and ensuring you get a better and stronger signal. So, look, great news for the telco industry and the phone companies. They'll have something new to sell, new equipment to the phone companies, new handsets to us. But at the moment, it's still in the minds of boffins as to how they're really going to make it all happen. And there are plenty of developments from Huawei and Ericsson and Nokia and others, but none of them have equipment ready to sell yet, and it's all still in the hype phase.
That's Alex Zaharov-Reutt from TechAdvice.life. And this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.